From the beginning? Okay. But okay, students are not writing. Okay, you can just. Okay, wait, cut off. Okay. It's okay, Master, I can wait. Oh, yeah, yeah. Good morning, students, and welcome again. Sorry for that. There was a problem with the connection, so I hope that you write again your number, your name in English, and of course, the class where you belong to. Okay? So that's it. We begin right away. So welcome to our class. This is Math for M3 of ACT IEP. And what are the objectives for today's lesson or today's session? These are, at the end of the session, you students should be able to name the three types of systems of linear equations and write the solutions to differentiate its type of systems of equations. You listen to the video from YouTube. It's from my YU channel, and I will cut the video maybe at the middle so that we can finish the lesson for today. So we do this. I will ask questions. Make sure that you have your paper. You write some words, important words, especially the three types of equations, because I will ask questions about it later. Okay.
Hello, I'm Professor Von Schmohawk, and welcome to YU. In the previous lectures, we saw how a race between a tortoise and a hare could be mathematically represented by a system of two linear equations. Graphing their distances method. Solving the system of equations gives us the coordinates of the intersection point, and thus the distance and time when the tortoise and hare are both at the same place at the same time. However, not all races where the tortoise and hare both travel at constant speeds would result in their meeting at one point in time. For example, let's say that instead of traveling at 1/2 mile per hour, the tortoise decides to use roller skates, which allow him to travel at the same speed as the hare. Since the two runners' speeds are the same, their graphs have the same slope, and the two lines are parallel. Since the two graphs never intersect, the tortoise and hare never meet. This system of linear equations therefore has no solution. Yet another possibility is that both the tortoise and hare start the race at the same time, and travel at the same speed. Their graphs therefore coincide, reflecting the fact that the tortoise and hare both have identical distance values at every point in time during the race. Since the two graphs intersect at every point, there are an infinite number of solutions to this system of equations. So there are three possible types of solutions we may encounter when solving systems of two linear equations in two variables. The first possibility is that the two graphs cross. Their single intersection point reflects the fact that only a single solution exists which simultaneously satisfies both equations. The second possibility is that the two equations describe distinct but parallel lines. Since these graphs have no point of intersection, no solution exists which can satisfy both equations. The solution set of this system is therefore the empty set. The third possibility is that the two lines described by the equations are the same. In this case, the two graphs intersect at every point, and the solution set contains an infinite number of solutions. These three types of systems are characterized by two attributes. The systems can be either consistent or inconsistent, and the equations in the system can be either dependent or independent. So what exactly do these terms mean? Any system of equations for which no solution exists is said to be inconsistent. And any system with one or more solutions is said to be consistent. The consistent systems we have seen may have a single solution when the equations describe different lines, or an infinite number of solutions when the equations both describe the same line. Equations which describe different lines are said to be independent, and equations which describe the same line are called dependent. So consistent systems with independent equations have one solution. Consistent systems with dependent equations have an infinite number of solutions, and inconsistent systems have no solutions. We can quickly determine which type of solutions we should expect by writing the equations in slope-intercept form. Let's say we are given a system of two linear equations in two variables written in standard form. If we rewrite the equations in slope-intercept form, y equals mx plus b, by examining the constants m and b, which correspond to the graph's slope and y-intercept, we can tell whether the system has one solution, no solutions, or an infinite number of solutions. If m is the same in both equations, and b is different, then the lines have the same slope but different y-intercepts, so the lines are parallel. Since distinct parallel lines don't intersect, the system has no solutions, and is therefore inconsistent. On the other hand, if the equations have different values for m, then the slope is different for each equation. Regardless of the value of b, the lines cannot be parallel and must intersect somewhere at a single point. The system therefore has one solution and is consistent. And since each equation describes a different line, the equations are independent. If the equations of the system both describe the same line, then they must have the same slope and y-intercept. So when written in slope-intercept form, the equations will be identical. Therefore, the system has an infinite number of solutions. Since the system has one or more solutions, it is consistent. And since both equations describe the same line, the equations are dependent.
Okay, so you remember all these? 1, 2, and 3 we have here with one solution, consistent system. and independent equations. Infinite number of solutions, students, meaning there are many, many solutions. It's more than one. We cannot count the number of solutions. It's consistent and dependent. And if there are no solutions, you see the graph here shows two parallel lines. They don't meet, but they have the same slope. So if you have the same slope, okay, here for example, this, sorry, from here to here, okay, and then the slope also from here, okay, from here to here, they have the same slope. They don't meet, so meaning there are no solutions. Okay, it means inconsistent system. So these are the three types of systems of linear equations. I'll ask you some questions regarding this. Okay, the first one, what are the three types of systems of linear equations in two variables? Okay, can you type your answer for this? Students, okay, do it quickly. Check some.
One. What are the three types of systems of linear equations in two variables?
One more.
1. What are the three types of systems of linear equations in two variables?
Write all three answers. Okay, I will check whether you can remember all the three systems of linear equations, types of systems. Okay, I will just wait for maybe three students to answer and then we move on to the next. Answer is one. What do you mean by that? Okay. The one with the no answer, unlimited answer, and one answer. What are the names of those? So what are the names? From who made of room 8, number 15? The one with one solution, the one with the infinite number of solutions, and no solutions. Those are according to the number of solutions. Can you write the name? For example, consistent and independent system. That's the first one, consistent and independent. Okay, write the answer, consistent and independent. What's the second? What's the third? Three answers, one comment. Three answers, one comment. From room 8 also, number 4, that's according to solutions. We have independent, consistent, dependent, consistent, and inconsistent. I will consider your answer correct from number 12 of room 8. Very good. Who else? Complete your answer, Chayapat of room 1. Complete your answers. Complete all your answers because there are two possible answers, consistent and independent, and the other one is also consistent. Who else? Independent equations, dependent. You have to complete, students, all your answers. Thank you for your answers. It should be, again, consistent and blank. Consistent and blank. And the last one with no solutions, what do you call it? Okay, I'll wait for one more answer because you have to do the words about you have to do these words for the homework later. Consistent and independent. Oh, I gave you already the first one. Consistent and independent. The second one. Fumit, what is it? Consistent and independent. That's the first answer. Only one student knows how to write the answer. Who is this? Tanya. Room 3, number 39. Independent, consistent, dependent. Okay, I will consider it correct. Tanya, very good. And from room 8. And one more. Independent, consistent, dependent, consistent, inconsistent. Chayapat, room 8, number 1. Check your spelling. Check your spelling. Okay, one more. Fumid, improve your answer. It should be consistent and independent. Consistent and blank. And the other one without solutions. Okay, okay. I will read all your comments later. Oh, this is it. Chayapat. Independent, consistent. Okay, that's correct, Chayapat. Congratulations, Chayapat. Tanya, and the other one from room 8 a while ago. I forgot already the number. Anyway, I'll check onto it later. Okay, the second one, because we don't really have that much time. Okay, this is it. So there's letter A, letter B. Okay, letter C, consistent and independent system. The second one, consistent and dependent. And the other one, inconsistent system. Okay, could you please say all the words at home alone? One more. Consistent and independent system. Consistent and dependent system, and inconsistent system. Okay, next. The second one, what do you call the systems with no solutions? What do you call the systems? Oh, sorry. Go back to, oh, it's number 2. Wait. So there's, wait. That's the answer. Oh, okay, anyway, next question. Where's number 2? I don't know. Anyway, students, number 3, the third one. Okay,
3. What do
is
you
the
call the
answer?
systems with no solutions?
The systems with no solutions is called inconsistent system. Okay, next is, I don't know, where's number 2? It's gone. Okay, anyway, number 1. Okay, what is the meaning of the slope? How steep a line is, and what is an intercept? It is a y-intercept. When we say y-intercept, it is a point on the y-axis where the two lines meet, or maybe one line meet. For example, okay, I'll show you the graph so that you will know what's the meaning of the y-intercept. Okay, so I need this one. Okay, this is, for example, the y-axis, and this is the x-axis. So this is the graph of the line. Example, okay, this is the graph of the line. And this point here, it is the intersection of the graph and the y-axis. This one is called the y-intercept. It is the point of intersection of the line and the y-axis. So this is y-intercept. Slope, how steep a line is. If you go to the mountain, like this, if this is the mountain and you have, okay, this is, for example, the mountain and you have to go up, how steep is it? Okay, so it forms a right triangle. So for example, from, can be go down, okay, down, and then okay, go down first, go down, okay, go down, and wait. Okay, let me say it's clearer. Can be like this, down, left, like this. So this is the slope of the line, or you can have it here. 1, 2, okay. You know about the slope, I think when you were in the previous, okay, sorry, it goes back, okay. Next, so these are the examples of the systems of equations. The first one, inconsistent system. So when we say inconsistent, there are no solutions. This is the second one, consistent and independent, consistent and dependent. So let's see if what can we do about this. The first one, inconsistent system. So you have to write in slope-intercept form. So meaning it is y is equal to mx plus b form. Okay. And this can be y is equal to, this is y is equal to 2x plus 5. Yeah? Y is equal to 2x plus 5, or you can do this. Y is equal to 2x plus 5. This is the first equation. The second equation is equal to y equals 2x plus 4. This is the second equation. So according to the video that we had a while ago, just look at the m. The m, this one here, is the slope. The m is the slope, and b is the y-intercept. In this case, we have the same m, 2 and 2. 2 and 2, but we have two different b's, which is called the y-intercept. The y-intercept here is 5, the y-intercept here is 4, so they don't have the same y-intercept. So the possibility for this graph would be this. Okay, the possibility would be this. Two parallel lines, they don't meet. They don't meet. They have the same slope, but they don't meet. That's why there are no solutions, and it's called inconsistent system. Okay, next is this. It's already in y is equal to mx plus b form, and this is what we call the m, or the slope. They have different slopes. So you just remember, students, if you the equations in slope intercept form have the different m, different m. Just remember, if they have different m, so these two lines will meet for sure at exactly one point. For example, this line number 1 with line number 2, they will meet at exactly one point. So just remember, different m or different slopes will give us two lines with one point of intersection. Next, the last is consistent and dependent system. It should be written in slope intercept form. This is the slope, this is the y-intercept. So it is already in y-intercept form. Just look at the slope, which is the m. Look at m. Look first at m, so we'll have here m, okay, m. Okay, and this is your B. Okay, your M here is 2, your B -1, -1. So these two equations give us, of course, identical equation. So if you have identical equation, what does it mean? If this is your y-axis and this is your x-axis, what does it mean, students? Meaning, there is only one line. This is line 1. And this is also line 2. So if you are asked how many solutions, you will answer infinite number of solutions, meaning we cannot count the number of solutions because this is line 1, example, and this is also the line for line 2. So if you are asked to count how many, you just answer infinite number of solutions. Okay, I'll write the word. There are infinite number of solutions, meaning cannot count because line 1, line 2 the same. How about here? How many? If you are asked how many solutions for consistent independent, the answer is only 1. Exactly 1 solution. How about here? Inconsistent solution. 2 parallel lines. How many? The answer would be none or 0. So there is no solutions. So once more, inconsistent system has no solutions. Consistent and independent system has exactly 1 solutions. And consistent dependent system has infinite number of solutions. So it's easy to tell if you write the solution, the equations in slope intercept form. Can we graph to find the answer? What type of equations are they? Yes. Can we do other solutions like solving? Yes. But this is the easiest one. Just write the equation in slope intercept form and look at the M and the B. If the M here the same and your B different, so meaning the graphs are two parallel lines. If the M here, M's different, values different. So meaning it's with 1 solutions or the point of intersection is only 1. You have 2 different lines, they have 1 point of intersection. So this is different M. So 1 point of intersection here. Same M, different B. So meaning we have infinite number of solutions. Okay? Next, we move on to the, okay, these are the graphs of what we had a while ago. Okay, no solutions. They don't meet. So parallel lines are examples of inconsistent system. And there's no solutions, meaning the graph do not meet each other. The second is this. They meet at exactly one point. So this is an example of consistent and independent system. And we exactly have one solution. Okay, the next is this. If you write in y equals mx plus b form, okay, that's it. This is line 1. This is also line 2. So we have infinite number of solutions. Yes, that's one. Infinite number of solutions. Okay. How about this? If I ask you a question, number 6, is the system of linear equations consistent or inconsistent? Again, number 6, is the system of linear equations consistent or inconsistent? Some of the questions a while ago were missing. I don't know why. Okay, who can answer? Just write first in y equals mx plus b form. Okay, just like no need to eliminate or something like that. So there's only this. Okay, do like this. Write in this form, in slope intercept form. This. Okay, so this would be equal to what? Huh? 2. Change the color. Okay, this would be 2y. This. Okay, equals. This is 13. And we have here, okay, so negative x plus 13. Divide by 2. Divide by 2. So this is y equals negative x over 2 plus 13 over 2. And this is number 1, equation number 1. So this would be our equation 1. This is number 2, okay? The second is this, second one. So we'll have here negative y. Okay, step by step. Negative y, let me erase this one. Okay, so it's clear. So it would be negative y, step by this one, equals. That's negative 11. 3x is minus 3x or negative 3x. Divide by negative 1 or multiply by negative 1. We get the same answer. And this is positive y or y. It should be in positive y or just y, not negative. So y is equal to, okay, negative 3 divided by negative 1 is positive. So we have here 3x. Negative 11 divided by negative 1 is equal to positive 11. And then just look at the slope. Look, slope or the m is 3. The slope here is negative 1 over 2 or negative 1/2. So I'll write it down. So maybe yellow. So m or the slope here is negative 1/2. The slope here, which is m, equals 3. So by just looking at the slope, they are different numbers. 3 and negative 1/2 are two different numbers. Remember, if they don't have the same slope or they have different slopes, it means this is what? Give me the answer. What kind of systems of linear equations are they if they have different slopes? Can you write down the name? Not Pacon, you already have the answer. What is this? Dependent, consistent. Can you write first the word consistent and blank? Consistent and blank. Not the other way around. Write, students, write consistent and blank. Chayapat, room 8, number 1. Consistent, dependent. How about from number 12 of room 8? Can you rewrite your answer? Kita touch. Number 4, boss, your answer is consistent, dependent. How about from, all of these students are from room 8. How about other students? Number 21, room 8, consistent, dependent. Room 6, number 35, pasa pa, consistent, dependent. And who else? Room 8 again, number 31, consistent, dependent. And the last one, number 12, consistent, dependent, system. Okay, what does it mean of consistent, dependent? What's the graph of this? Okay, already, okay. This is consistent loop. Okay. Number 6, you look at number 6. Okay. Why it is consistent and independent system? Students, what does it mean of consistent, why independent system? A while ago, okay. Is the system consistent and independent? When we say consistent and independent, what does it mean? What is the graph of it? Okay, type your answer below. If it is consistent and independent system, what is the graph of it? Are they parallel lines? Or are they lines that meet at exactly one point? Or these lines, these two lines are identical, meaning they have the same line. Oh, what is this? Tinakrit from room 1, number 13. They have one point that a line cross each other. What does it mean? Tinakrit, you mean there is one point of intersection. Who else? The line meets together from room 4. Okay, Chayot, room 8, number 8. They meet at exactly one point. Chayot, your answer is very simple yet so clear. Who else? The line meets together. It's consistent and independent system. Independent. Meaning what? Who else? Okay, your answers are all correct. Chayot, Tinakrit, and who is this? There's no name in English. Room 8, number 4. The line meets together or they have exactly one point of intersection. So if you graph it, it would be this. This is one of the possibilities. Okay, like this. They have different slopes. I already mentioned a while ago, different slopes or different letter M. They have different letter M here. If you write it into y is equal to mx plus b, and if you write this into y is equal to mx plus b, they have different M or different slopes. So it's considered consistent and independent. It is only consistent and dependent if the two lines do not meet. If two lines do not meet because they are parallel lines. Okay, next would be this. Number 7. Okay, do it number 7. Students, what kind of systems of linear equations are they? 3x plus 2y is equal to 6. 6x plus 4y is equal to 12. Okay. Answer on your paper. Step 1. Write into y is equal to mx plus b. And find the m. Look for m. Look for b. Compare. Okay, Chayot, what is your answer? Inconsistent. Kititach, what do you mean by one line? What kind of system of equations are they? Name. What's the name? Chayot, your answer is inconsistent. Room 8, number 12 is also inconsistent. Yes, I want the name. Name of the system, students. Tinakrit. Room 1, number 13 is consistent. Let's see. Okay, and the other one, Chayapat, room 8, number 1, consistent and independent. Let's see. I prepared a slide for the solutions. Okay, this, number 7. Let's see if it is inconsistent or consistent. 3x plus 2y is equal to 6. Okay, solutions, SOL. Change my color to white and then I'll do it. Okay, so that's 2y. So step by step, 2y is equal to 6, positive 6. That's 3x. So this is negative 3x plus 6. Okay, divide by 2. Divide by 2. This is y is equal to negative 3 over 2x plus 6 over 2 is 3. This is equation number 1. And the slope here is equal to negative 3 over 2. And the b is equal to 3. Okay, how about equation number 2? Okay, and make a line. Okay, equation number 2, step by step, for y is equal to 12, positive 12. Yes, and that's minus. Okay, divide by 4. Okay. Divide by 4 each of the terms. So y is equal to negative 6 over 4, also negative 3 over 2, x plus 12 divided by 4 is 3. The slope here is equal to negative 3 over 2. And the y-intercept, which is b, is 3. Compare your answer. Okay, I'll use red. Okay, this is negative 3 over 2. This is also negative 3 over 2, which is the same. How about your b? b is equal to positive 3. b is equal to positive 3. Meaning, equation number 1 and equation number 2 are called identical lines. They are the same. They are the same. So the possibility would be this. This is line 1, line number 1. This is also the same. This is line 1 at the same time, line 2. So if you are asked, how many solutions are they? How many points of intersections are they? You will answer, Miss, cannot count. Correct. Or there are infinite number of solutions. Tinacrate, correct. So what kind of systems of linear equations are they? I want the name. I want the name. Since line 1 is equal to line 2, you see, they're the same. You simplify, they're the same. So this is the graph, possibility for the graph. So what kind of systems of linear equations are they? Chayapat, room 8, number 1, consistent, independent. Tinacrate, room 1, number 13, consistent, independent. What do you mean by independent? Okay, consistent and dependent. Chayapat, room 8, number 1, you change your answer to the correct one. That's the answer. Tanya, room 3, number 39. That's correct. Tinacrete, is that your answer? Look at your answer. Okay, can you type one more or two more students? Okay. Yes. Correct, Tanya. Correct, Chayapat. Tinacrete, are you sure with that? Kanta. Kanta? Kanta, room 2, number 47, correct. And room 8, number 8, Chayut, consistent, dependent, correct. And room 8, number 31, room 8, correct. Araya, room 3, number 35 is correct. Yes, Tinakrit, correct. That's it, correct, students. Very good. Okay. What is it? Consistent and dependent. Okay. The last one. The last one. Okay, do it by yourself, students. And answer what type of systems of linear equations are they? Okay, the last. Because we don't have much time and you have to scan your homework. Okay, the last. You can apply elimination method or you just use y is equal to mx plus b. Chayot of room 8, number 8, you're too fast. Inconsistent. Okay, let's see if your answer is correct. I'm waiting for 4 more students. Chayapat, room 8, correct? Oh, room 8, you're too fast. Chayut, room 8, number 8. Not Pakon, number 31, room 8. And who is this? Araya, number 35, room 3. And number 12, room 7. Inconsistent. How about from room 5? Students, room 5, room 6, room 4. Why you don't have the answer? Try. Room 7, there's your answer. All of your answers are correct. Monrodi, number 49, room 3. Room 4, room 5, where are your answers? Room 4, room 5, room 6. Why you don't? Where is Pawarit, master? Pawarit, ade, chinachot. Yes. Yes. Did you copy the, oy, no, no answer. No answer, China Chot. Room 5, number 23. Welcome to our class. You're late. Oh, who else? Who is this one? Pawarit, correct. Kantira, correct. Room 5, welcome. Your answers are all correct. And who else? Kanta, room 2, number 47. Room 1, number 34, correct. And many more. Pasapa, room 6. Room 6, Pasapa is here now. Number 35 is inconsistent. How about Mark? Mark of room 6. Am I right? Where is your answer? Who is Mark? Room number 7? How about your... Okay, Mark, the class leader. Lam, the class leader of room 4. Where are you? Can you give the answer? Ornalyn, correct. Many, many more answers. Thank you for your answers. And the answer would be... Wait. Yes, all correct. Inconsistent system. Okay, maybe how many more minutes? 5 more minutes. Okay, I'll do this fast. And then you have to scan your homework. Okay, this is it. 2y. 2y. Step by step is equal to 6. Now, okay, negative 3x. Or you can divide by 2, divide by 2, yeah? Y is equal to negative 3 halves x plus 3. M is negative 3 halves, B is 3. This is equation number 1. The other equation, okay, divide by a line, this 2y is equal to 12, positive 12 or plus 12. And this is negative 3x, divide by 2, divide by 2, and y is equal to negative 3 halves x plus 6. Can you see it? Okay, so you see they have the same slopes. M1 equals M2. And they have the same B. B1 equals B2. Okay, they are the same. So meaning, what does it mean, students? If they have the same, meaning what is it? Inconsistent system. Okay, do your homework. Okay, we don't have much time for this. These are the 3 types of systems of linear equations: consistent, independent, which is with one solution; consistent and dependent, inconsistent system with no solutions. Okay, don't have time for questions. I hope that you don't have that much questions. You can rewatch the video and scan. Okay. So this is what is inside, but this is blurred, so you have to follow what is it there. So you just search for the words, 8 words, 8 words. And then you just connect using color pencils or using your tablet, your computer. No need to copy, just do it using your laptop or your, what is it, students, your smartphone or your tablet, any. No need to copy, and then send to our line group on or before, today is Tuesday, on or before Friday, okay, before 4 p.m. Okay, this is the end, students. Okay, do you have questions? 1 more minute. Okay, if you have a question, you ask in 1 minute. I will read your questions. No more questions? Oh, why are you quiet? No more questions, students? Okay, I hope to see you face to face next time. Okay, take care and don't forget your homework, especially those who were not able to do all three homeworks. Okay, and today's homework is easy. Question, what is your question? No more? Okay, so this is the end for today's session, students. Thank you for coming. It means that you really would like to learn something about math today. Bye-bye and see you around.